Okay, we're going to try and find the resultant force, R, the distance at x away from our point A, and we're also going to find the angle it acts at. I'm going to call that theta. So we're going to find the resultant force. So a resultant force is a force that replaces the sum of all of these forces, the angle it acts at and the distance it acts away. So basically we're trying to find the resultant. Let's just say our resultant is there. Okay, we don't know where it is yet, we'll say it's there. R. The angle it acts at beneath there, we'll call that theta. And then we've got to find the distance it acts from there, which is this distance from there to there, and it's the distance x. So the distance we're trying to find is the distance x. So the resultant replaces the sum of all these forces, x is the distance, and the angle at which it acts. Now, each of these forces are vertically down, but these three forces are at an incline. They're at 90 degrees to the rafter, this top member, but they must have different components to them. They have a vertical and a horizontal component. So what we can say is that if we take just one corner, we say that that is acting at 30 degrees to the top rafter, so a tie member. Our force, F, this one, is made up of a horizontal component, Fx, and a vertical component, Fy. And the angle in here is the important thing, because we've got 30. We said that is 90, so this angle in here is 60 degrees. So what can I say? Well, I can say that Fx, using trigonometry, is F the cos of 60, and Fy is F the sine of 60 degrees. So I can find or resolve these forces. Now, to find the resultant force, well, my resultant force is a force that replaces the sum of all the other forces. So if we said the sum of the horizontal forces was Rx, and the sum of the vertical forces was Ry, the resultant is R. And if I just take a little bit of trigonometry and Pythagoras, I can say that R is actually the root of, well, hypotenuse and the sum of two sides, Rx squared plus Ry squared, and theta will actually be, well, the Ry over Rx. So I can resolve, I can find these. So let's start. Well, we'll start by finding the horizontal component of these forces. It'll give us Rx, but we'll just start by finding Fx. So what we have, what we've got, yeah, to find horizontal Fx is equal to F cos theta. So Fx is equal to, well, I've got the three forces, 2, 2, 4, 0 plus 1, 1, 2, 0, the sum of the forces times the cos of 60. So it's going to give you 4480 cos 60 2240. newtons. And although it's Fx, there aren't any other horizontal forces, so it's also going to equal, in this instance, Rx for me. So I know what that is. Now, to find the vertical components, Fy, well, I got to go first find the vertical Fy. Fy is going to equal F the sine of 60, 1120 plus 2240 plus 1120 all times the sine of 60. So that's going to equal 4480. So the sine of 60, which is going to give me 387.979 newtons. So that's actually the vertical components, but actually want to find y. I'm going to actually just say, okay, ry is going to equal, well, it's going to equal 387.979 plus, what's going to equal that one, and that one. It's going to equal 3,000 plus 2,000, 1,069, 369 Ry. It's going to equal 9879.79 newtons. So I know Rx and I know Ry. Let's give ourselves up. So we now know that Rx is equal to 224 newtons and Ry is equal to 979.79 newtons. And we want to find the resultant force, R, which is going to act that way. We said that R is going to equal the root of Rx squared plus Ry squared, which is going to equal the root of 4 squared plus 979.79 squared. So R is going to equal 10130.54 newtons. So I found the resultant. And we want to find the angle. We want to find the angle theta. And we said that theta is equal to Ry over Rx. So that's going to be 9879.79 divided by 2240. That gives me 4.41110 to the minus 1. So theta is equal to 77.2